All right, in this lesson, we are going to multiply and divide rational polynomial expressions. So the skills that are included are factoring, being able to understand when a value might be excluded, applying multiplying and dividing fraction rules, and then simplifying fractions. So by the end of this lesson, you will be able to take this expression and to be able to multiply or divide them successfully. All right, so let's do some quick refreshing of our elementary school math. 4/5 divided by 20 over 15. See if you can do the math by hand to divide these two fractions. So hopefully you remember that dividing, we're actually going to multiply by the reciprocal. So just like dividing by 2 is the same as multiplying by 1/2. So we're actually going to take 4/5 and we're going to multiply it by the reciprocal, which is 15 over 20. Now, I could multiply across and then simplify. So I can multiply and then simplify, or I can simplify and then multiply. So if I simplify first, it makes my life easier, but I have to be aware of my numbers. So if I'm going to simplify first, I'm going to look at numbers in the numerator and numbers in the denominator that can both cancel or that have something in common. So for instance, when I think about 4 and 20, I know that 4 can go into both of those, and 4 goes into 4 one time, and 4 goes into 25 times. And so then I'm going to look at 5 and 15, and I know 5 goes into both of those. So 5 goes into 5 once, and 5 goes into 15 3 times. And so I end up multiplying 1 times 3, and I get 3, and then 1 times 5, and I get 5, and I can't simplify 3 over 5, and so that's my answer. So the biggest thing with division is remembering to multiply by the reciprocal. All right, so these are my guiding questions as I think through multiplying and dividing rationals. So first of all, I need to pay attention. Is it multiplication or is it division? If it's multiplication, then I can just move on. It's division, I need to remember to rewrite it as multiplication. Okay, my second question is, can I factor any of the numerators or denominators? So I need to pay attention to double factoring, so like factoring and then factoring again, seeing if it can be factored further. I also need to look for if the leading coefficient is negative. So I'll need to remember to take that negative out if it is. My third question, what are the excluded values of the rational expression? So we're starting to get into a function where there are certain values that x cannot be, and we'll talk about what that means. And then, can any values cancel? And we're going to talk about package deals or monomials, and then what is my simplified answer? So let's go ahead and get started. So first of all, is it multiplication or division? It's multiplication, so I'm good. I don't need to multiply by the reciprocal, so I can move on. And then can I factor any of the numerators or denominators? So when I look at 6r minus 42, I notice that there is a GCF, and so I can take a 6 out. So when I take a 6 out, I'm left with r minus 7. So I'm just rewriting that numerator as 6 times r minus 7. r plus 1 cannot be factored. But 4r plus 4, I can take out a 4, and that leaves me with r plus 1. And then 6r minus 54, I can take out a 6, and I'm left with r minus 9. All right, so I factored everything, and so I'm just going to put everything together now. So what I essentially have is I have 6 times r minus 7 times 4 times r plus 1. So in multiplication, order doesn't matter. So I'm actually going to multiply these little loose numbers out front. So 6 times 4 is 24. And then I have r minus 7 and r plus 1. So I've got, those are package deals. They go together. I can only cancel things that look like that. And then in the denominator, I only have a 6 loose, and then I have r plus 1, that binomial, and r minus 9, that binomial. So when I think about what are my excluded values, so if you remember back to the very beginning of the semester, we talked a lot about rational, and it has that asymptote at x equals 0. And the reason is because if I think about the parent graph, 1 divided by x, so there's only one number that we never, ever, ever can divide by, and that's 0. So in this case, x cannot be 0. So the domain is any number except for x cannot be 0, because if I put 0 in for x, I would be dividing by 0. So what I need to do is I need to look at the denominator, and I see that there are two r's in the denominator factored form. So that means that there are two values that r cannot be. So in this case, r plus 1 cannot be 0, and r minus 9 cannot be 0. So before we ever simplify anything, we have to state my excluded values. So r cannot be -1, and r cannot be 9. So it's really important that we know those excluded values for later on especially. All right, so those are my excluded values. So then can I cancel anything? So I can cancel monomials with monomials, and I can cancel binomials with binomials, but I cannot cancel monomials with binomials. So I'm going to start with 6 and 24, so my two loose numbers at the front. So 6 can go into both of those. 6 goes into 6 one time, and 6 goes into 24 4 times. R minus 7, there has to be an R minus 7 in the denominator for it to cancel, so there isn't, but there is an R plus 1 and an R plus 1. So when they cancel, it's like 4 over 4 becomes 1, R plus 1 over R plus 1 becomes 1. So then I have my simplified answer. So what's left on the top is 4 times 1, which is just 4, and then I have that R minus 7. All over, and in the denominator, 1 times 1 is just 1, r minus 9. And that is my simplified answer. The last thing we're going to do is, we're not going to be assessed on this, but you need to be familiar with how to write the domain. So if you think about a normal domain is usually negative infinity to positive infinity. All right, well, we have two breaks. We have a break at -1 and we have a break at 9, where those are two values that they cannot be. So it could be everything up to -1, and then everything right past -1 up to 9, and then everything from 9 to infinity. So we're going to write that. So essentially, it's going to break at -1 and it's going to break at 9, but it's going to go from negative infinity to infinity still. So we're going to write it as from negative infinity to -1 are all numbers that are allowed to be in the domain, and we're going to combine that with all the numbers between -1 and 9, and then we're going to combine that with all the numbers past 9 to infinity, and that is my domain. And like I said, you're not going to be assessed on that, but I want you to be familiar with that concept and how to write that. All right, we're going to look at example 2. We're going to go through that same thinking process. So is it multiplication or division? Well, it's division. So really what we're going to have to do is multiply by the reciprocal. So I'm just going to rewrite it. So 3x plus 15. If you want to factor it as you rewrite it, that is totally okay. It'll save you a step, but I'm going to do it step by step right now. And then I'm going to multiply it by the reciprocal. So 18x to the third plus 6x squared, and then in the denominator, x squared plus 11x plus 30. All right, so it's division. I rewrote it. So now can I factor any of my numerators or my denominators? So when I look at 3x plus 15, I can rewrite that as 3 times x plus 5. And then in the denominator down here, I can take out a 6x squared, and I'm left with 3x plus 1. And then x squared plus 11x plus 30. A is 1, so I'm looking at the factors of 30 that give me 11. So that's x plus 5 and x plus 6. And then this denominator, or this numerator, I can take out a 6x squared, and that leaves me with 3x plus 1. All right, so I'm going to rewrite all of that together. So I'm going to multiply any loose numbers together. So over here I have 3 and I have 6x squared. So that becomes 18x squared. And then I've got x plus 5 and 3x plus 1. And then in the denominator, I just have that 6x squared. There's no other loose numbers. But 3x plus 1, x plus 5, and x plus 6. All right, and then what are my excluded values? So the denominator, I have an x here, I have an x here, I have an x here, and I have an x here. So I actually have 4 excluded values. So 6x squared cannot be 0. 3x plus 1 cannot be 0. X plus 5 cannot be 0. And x plus 6 cannot be 0. So in this case, x cannot be 0. Here I would subtract 1, which is negative 1, and then divide by 3. So x cannot be negative 1/3. Here I would just subtract 5, so x cannot be negative 5. And here I would subtract 6, so x cannot be negative 6. So those are all of my restrictions on the domain. So it's all the x's except for those 4 values. All right, so once I've stated my excluded value, now I can see if there's anything I can cancel. So 18 and 6 can cancel, so 6 goes into both of those. 3 times for 18 and 1 time for 6. X squareds are going to cancel, and they just cancel with each other. X plus 5 is going to cancel, and 3x plus 1 is going to cancel. So in my numerator, I just have 3 times 1 times 1 times 1, which is just 3. And in my denominator, I have 1 times 1 times 1 times 1 times x plus 6. So my final answer is just 3 times x plus 6. I'm sorry, 3 over x plus 6. All right, so example 3. We're going to go through together on this last one, and then I'm going to let you start trying some on your own. So is it multiplication or division? I see that it is division. So I'm going to need to multiply by the reciprocal. So what I was saying earlier is if you want to factor it as you go, you can. So I notice in this first one, I can take a 15 out, and that leaves me with b minus 2. And in the denominator, I'm going to take out a 40b squared, and that leaves me with b minus 2, and I'm going to multiply that by, and now the numerator is going to go to the denominator, and while I do that, I notice that it's not in standard form, so I'm actually going to rewrite it, negative 14b to the third plus 7b squared, and when I look at that, I can take out a negative because I want my first term positive. So that was one of the leading coefficient that's negative. So I'm going to take out a negative 7b squared. So I'm going to go ahead and do that right now. And I take out a negative 7b squared. And when I do that, I'm left with 2b minus 1. And then in the denominator, which becomes the numerator, I'm taking out 8b squared. And that leaves me with 2b minus 1. So I did that, and now I'm going to combine everything into one multiplication. So I'm going to multiply my loose numbers, so 15 times 8, which gives me 120b squared, and then I still have a b minus 2 and a 2b minus 1. And then I'm going to multiply 40 times negative 7. And I get negative 280. And I also have a b. Now I have b to the fourth because I have b squared times b squared. And then I've got b minus 2 and 2b minus 1. So when I'm stating my excluded values, I have 3 of them because I have 3 b's. So in this case, it's just going to be b cannot be 0, because anytime it's just a coefficient in a number, it's not a binomial, it's a monomial, that's just b cannot be 0. This case, b cannot be 2, And in this case, b cannot be, so I would add 1 and divide by 2, so that's 1/2. So those are my restricted values. All right, so once I have those restricted values, now what can cancel? So 2b minus 1, 2b minus 1, b minus 2, b minus 2. I have 2 b's here and 4 b's here, so I'm going to be left with 2 b's on the bottom. And then 120 and 280. So I know they're both going to divide by 10. So then I'm thinking about 12 and 28. So 4 can go into both of those. So 4 is going to go into 12 3 times, and 4 is going to go into negative 28, negative 7. So what I'm left with in the numerator is just 3, and in the denominator, negative 7b squared. And that is my final answer. All right, so what I'd like you to do is I'd like you to pause the video and see how far you can get on your own. All right, so hopefully you saw that it's division, so we needed to multiply by the reciprocal. So as I was rewriting it, I ended up factoring it. So this first one, the a is 1, so I'm just looking for the factors of 48 that add to be 14. So 6 times 8 is 48, and 6 plus 8 is 14. And in the denominator, I'm looking for the factors of 48 that subtract to be 2, and I want it to be a positive 2, so it's going to be x plus 8 and x minus 6. And then I flipped these, so both of them I can take a 9 out, but in the denominator, which becomes the numerator, when I take a 9 out, I'm left with x plus 1. And in the numerator, when it becomes the denominator, I took a 9 out and I was left with x plus 6. So then I rewrote it as one big fraction. I put my loose numbers out front, and then I just listed my binomials. And then I started I listed my excluded values. So I had 3 x's in the denominator, so I had 3 values that x could not be. And then I started canceling, and my 9's canceled, and my x plus 6 canceled, and my x plus 8 canceled. So I was left with 1 times 1 times 1 times x plus 1, so that's just x plus 1, and then 1 times x minus 6 times 1 times 1, which is just x minus 6, and that's my final answer. All right, go ahead and pause the video and try example 5 on your own. All right, so when I multiplied these two fractions out, I ended up with v plus 9 over v plus 5, and I had 3 excluded values for v. V cannot be negative 5, v cannot be 5, and v cannot be 6. So if you did not get that, go ahead and pause the video, look over my work, see if you can identify where your mistakes were. If not, make sure you write down questions that you need to ask. All right, you're going to pause the video and try example 6 on your own. Now keep in mind, this is like a whole number. So think about how I can write a whole number as a fraction. All right, so hopefully you are able to get that the final answer is 2 times n minus 10. And n cannot be negative 4 or negative 1. So go ahead and look over my work if you didn't get that. Identify your mistake. If you still have questions, make sure you write that down. All right, we're going to do more examples in class, but for right now, that just gets you the gist of multiplying and dividing rational expressions. So I'd like you to write a summary. So what is this lesson about? What are 3 errors you think students tend to make when adding or subtracting? And then what questions do you have still?